past the hour. So let's start. Welcome, everyone. Thank you for joining the session. Those who are online and those who are watching us, those who are here on Zoom session and those who are watching us online through different platforms, whether on Facebook or iSoc Live or through Twitter. Thank you for joining. I am Aftab Siddiqui. I'm part of the Manners Initiative, working for Internet Society, based in Sydney, Australia. I have with me Philip, who will be our instructor or the person who will be conducting the workshop. Philip is a good friend of iSoc, a good friend of mine, a good friend of the community, who's been helping the community, who's been sharing the knowledge with the community for quite some time. And today he will be sharing something about GitHub, Git and GitHub for network engineers. So I will not go into the details further. I'll let him explain it further. But before I go there, let me take this opportunity to acknowledge that we have Dr. Philip Smith on the session online, who, depending upon the time zone, a few hours ago was inducted as the Internet Hall of Fame for his amazing work in the community for many years, since the day I can recall, like 2006, I can recall that. And it's been an amazing journey for him, and it's not over yet, I would say, Dr. Philip. So it's just the, I would say, midpoint. It's not the beginning, it's the midpoint. You still have to do a lot. So really glad to have you on board, and it's an amazing feeling to have you as a mentor of the community, and being inducted in the Internet Hall of Fame. So thank you for your all the efforts and work you have done for the community, and congratulations.
Thank you very much, Aftab, for your kind words. I don't know, about halfway through, I've been doing this for 30 years or more. So I'm like,
it's just
I'm sure the next generation must be coming very close to being ready. But thank you.
Yeah, it's a midpoint. I said it's not the beginning. I would say it's still a midpoint. You still have a long way to go. So yeah, we'll keep you occupied with a lot of things. So don't worry. So over to the other Philip Paeps. It's all yours.
All righty. Let me begin by embarrassing myself by doing the slideshow thing, where I lose my window and then I click share screen, and then I hope I pick the right window. All right. If all is well, you should see my slides. Is that right, Aftab? I see nothing anymore.
Yes,
absolutely. Yes.
All right. Good. Excellent. This is titled a workshop. It's not really a workshop. It's me talking through revision control, Git, and GitHub. I am generally a software engineer. I work primarily on large code bases, operating systems, tens of thousands of files, and revision control is just something I do. Network engineers have a different view on the world, and revision control is important there as well. Unfortunately, all of the documentation and all of the how-tos and all of the introductions and tutorials and workshops seem to be targeted at people like me and less at people who do networks. So Aftab and Max asked me to do a kind of workshop, or to try to condense the Git and GitHub documentation and workflows in a way that network engineers can understand. And hopefully this will contribute to better collaboration in the network operation ecosystem. So I have a horror of agendas, but I'll put one in anyway. The first half or so of this presentation is going to be a Git survival kit, where I go through the Git book, the fantastic Git book, and only talk about the things that are relevant for network engineers and ignore all the other bits that just get in the way. If you're a software engineer and you're familiar with Git, you might want to make a cup of tea and put me on mute or something, because you're going to get bored and or angry because I'm skipping bits that are not relevant to network engineers. After that, I'll go through GitHub and the collaboration features that GitHub has and show off a little bit about how that can work for the Manners community and any other network community you might be part of. So next slide. So let's go take back a step and talk about the essentials of revision control. And the fundamental principle here is computers are better at remembering things than you are or than I am. So revision control systems remember things for you. They're essentially an external memory unit, and all the data you put in them, you can get out again at a later date, and you can go backwards and forwards in time, and you can merge bits and pieces from your history. And this is handy for software engineers when we're working on many files and operating systems or applications, but it's also handy for network engineers because your configuration is morally equivalent to code, a Cisco or a Juniper config file, or your DNS configuration, or your RPKI. Anything network related is really just code in another format. So it makes sense to track it in a similar way to code. It's not just for source code and configuration though. So revision control systems don't really care about what data you put in them. You can also use them to track changes and collaborate on other things in many different problem spaces. So for the networking community, the obvious ones that come to my mind are things like intranet drafts or network policy documents, but also training materials and presentations. Having said that, Git and other revision control systems are much better at dealing with text-based data than with binary data. So if you push in PowerPoint presentations, it'll work, but it's not going to be quite as gratifying as tracking text-based data. There's ways you can work around this by writing your presentations in HTML or something, but I haven't quite gotten quite that high on the Kool-Aid. But so this presentation is all about the principles, not really about the data you put in them. I'm going to be manipulating text files because they're what I have. You can put anything else in revision control as well. And the revision control system will be able to show you the metadata and what has changed, but things like showing differences will be a little bit more difficult if you're tracking binary data. So there's 3 different options of revision control in general. In rough terms, you've got no revision control at all, which you've got loose files all over the place and chaos reigns. Maybe you keep a copy of some files now and again and call it configuration 1.working or configuration 2 that might be broken. And you end up with a lot of different versions of essentially the same files, and it's difficult to keep track of them. It's an easy system to learn, but it's very easy to confuse yourself, and it's almost impossible to undo changes when it turns out that they're a bad idea, unless you're really, really careful. So let's not talk anymore about that. Another popular option for revision control is just archiving things for posterity. And then you might put them in a safe place, like you might stick them on NFS or a shared volume or OneDrive, Dropbox, what have you, or Domino if you're into crimes against humanity. That allows you to audit your changes and roll back your previous versions, so you can write little essays about them, and you can do more or less simple things and make sure that you can go back to something that works, or you can try out things. Unfortunately, this gives you concurrent access nightmares. If you're 2 or 3 people working on the same files, one person makes a little mistake, and suddenly history is gone, or there's corruption in the history, and it just becomes a nightmare. So finally, at the bottom end of this table, you've got proper revision control, which gives you full control over your revisions, over your changes, provides you with rich history of what has changed and why, at least potentially. Unfortunately, this comes with a learning curve. Historically, you had things like CVS and Subversion, which had a fairly shallow learning curve. You just, you have a file, you check it in, and when you're done with it, you share the file, you check it out, you check it. It's very simple. But now we have Git, and Git is complicated. So most revision control systems look roughly like this. On your computer, you'll have a file checked out, and it'll be connected to a version database. You'll have version 1, 2, 3 of that file locally. And when you work together with other people, you'll have a central server, and you can all see those files, and you check them out, and you manipulate them, and you go backwards and forwards between them in ways that make sense, and you communicate out of bounds. Git is more complicated, and it defies definition. Is it a revision control system? I don't know. Is it a content addressable file system? It's a good way of describing it. And why would a network engineer want to use something as complicated as Git? Earlier today, I was exchanging email with the other Philip, and this XKCD comic came up again. If you believe the authors of Git, it's an open source distributed version control system which can do all sorts of things. If you believe anyone who's used Git, it's a bunch of tools that, as long as you remember when and how to use them, they work. And if things break, just download a new copy of the codes and carry on. For the rest of this presentation, I think it's important that I remind everyone that Git is a piece of software, and GitHub is a company that provides a cloud service that's built around Git. You could use GitHub without Git, but not very well. And you can use Git without GitHub perfectly well. So the revision control system is Git, and that's what the beginning of this presentation is about. The cloud collaboration service is GitHub, and we'll talk about that a little later. The primary interaction with a revision control system is the commit message. And I put this slide early in the presentation before we even get into writing commits or committing code or putting anything in the revision system. The point of the system is to be a notebook or a diary or reminders to your future self. So you want to be nice to your future self. What Git does is it puts your files together with an explanation of what they're for in a system. And when things break, or when you're trying to understand what's happening on this network or what's happening in this system, the first thing you're going to look at is the revision control history. And if all that says is, I did some things, some stuff happened, or this makes sense, you're not going to benefit a lot from your revision control system. So whenever you're typing commit messages, think of them as notes to your future self. And even better, think of them as notes to your future self in a crisis. These are the things you will read when you are angry because everything is broken around you. You'll also read them while you're, getting productive things done, but they will be particularly handy when everything is on fire. As the comic says, Git is a bag of tools, and it has hundreds of little commands, and they're all a little bit obscure, and there's manual pages, and different commands do different things under certain circumstances. I've gone and listed about 13 commands, I think, or 14, one of those numbers, that you actually need every day. You need, as a network engineer, you don't really care about branching, merging, or integrating changes from hundreds of people who might be tracking different versions of your operating system. All you care about generally is your stuff, and maybe you're sharing it with a couple of other people. Your history as a network engineer is generally going to be linear, at least per device. You're not going to, you might have multiple different configurations in your network, but not hundreds or thousands of them that are different, or, unless you're doing something really strange with the way you're using Git. So all the commands you really need are these, and we'll show a GUI in a bit as well. And all the other commands you just stop worrying about. Just ignore them. If a manual tells you do these things, you probably don't actually need it. Moving on, I will do a 5-minute introduction demo with a new repository. And this is the other bit where I go and embarrass myself with sharing a screen. See if I can find a terminal window. Here we go. So, all right, you need to get your hands on a Git repository. Either you clone someone else's repository, but for experimentation, you might as well just create a new one. So I will just create a new one. My test repository. This is my network. This is my network configuration. How do I turn this directory into a Git repository? It's very simple. I just type Git in it. There we go, that's done. You now have an empty Git repository for your enjoyment. You can also create Git repositories with source tree or other GUI applications. We'll come to that in a moment. But the GUI is not very good at creating new repositories. Also, as we'll see later, you'll probably create your repository on GitHub and clone it. So I'm not going into the many little menu options of convincing source tree or other GUIs to create a repo for you. So having created a repository, let's stick some data into it. The usual README file is always good to have, and I just did something dumb because I can't type. There we go. That works better. So I've just created a README file for my repository. If you've got a keen eye, you notice that my shell is smart. It knows that I'm in a Git repository. On the left side of my shell, it just tells me I'm currently on the main branch. And as soon as I created a file, it put up a little question mark for me to say, okay, there's a file here. I'll just tell Git. So Git at this point knows nothing about this file. It knows the file exists, but it's not tracking it. If you do Git status, it will tell you that, hey, you are on the main branch. There's no commits yet, which makes sense. It's a new blank repository. And it tells me that there's one untracked file. So Git knows nothing. If I delete this file, Git will realize that it's gone, but it didn't know anything about it. So it's gone forever. To actually save this file in the repository forever, you need to Git commit that file. But before you can commit it, you first need to tell Git about it. So other revision control systems, you can just commit straight away. Git has a little intermediate step called the index by software engineers and the staging area by anyone who doesn't think in terms of indices or indexes. So let's add this file to the staging area with Git add, very straightforward. If I gave it a file, things will work better. So the Git user interface has become a little bit friendlier over the years. Previously, it would give you annoying little errors. Now it actually gives you a suggestion. So now we've added this file. So if you git status, Git will show me, right, there's a new file. When I commit, that file will enter the repository. So let's do that right away. If I type git commits, Git prompts me for a diary entry. Dear Philip, please write something meaningful about this file so that in the future, when everything is on fire, it will be helpful to you. So I will just say first commit, and maybe this configuration probably works. There we go. Save that file, done. This file is in the repository forever. This change can never get lost. I can always go back to it. I can always find it. It is safe forever. If I go and delete this file, I can always get it back as long as I don't delete the Git repository itself. So that's in a nutshell how it works. Let me stop sharing this terminal window and go back to my slides for a moment, if I can find them. To do this, that, and oh, come on. You'd think that after 2 years of people using Zoom, the software would manage to share screens better. So that's your first 4 Git commands: git init, git add, git commit, and git log. With these 4 commands, you can use Git effectively as a software engineer. You will be able to go back to your previous files. You'll be able to use your history for good, and you'll manage to get something done. But these 4 commands by themselves are not really all that helpful. So before I go on, let's talk a little bit about how Git thinks about your data. I've mentioned the commits, and a commit is really just a snapshot of your repository at that point in time. And it's important to remember that it's a snapshot of your entire repository. So it's a snapshot of the entire directory that's managed by the git init command you did first. Git does not track individual files. It's not like CVS or Subversion, where every single file has a history. Instead, Git tracks your entire tree. So every file is tracked at the same time. And if you make changes to files and you move them around, Git tracks this in its snapshot. So when you do a Git commit, what you get is a snapshot of your entire repository at that point in time, which includes the contents of your files, but it also includes metadata of the files. It includes their permissions. It includes where they are. And this is different to Subversion or CVS. Git tracks more, it tracks the entire repository. Also, Git version numbers are a bit strange at first sight, where things like CVS and Subversion have a number. You know, this is version 1, version 2, version 3. What Git does is it references each snapshot by the checksum of what's in the snapshot. There's lots of good reasons for this. It provides integrity, but it also makes it easy to go backwards and forwards in time. It's an integral part of the data model Git uses. It's also important to remember that most Git operations are local. Your repository is on your machine. You can commit with reckless abandon without sharing your history with anyone. All of your changes are local until you choose to share them. When you do share them, they're out there forever. So you can't remove history, or at least not easily in the way you could with older or more traditional revision control systems. It's also worth noting that Git generally only adds data. It is incredibly difficult to lose data once you've committed it, partly because of the way these checksums work, but also partly because of its internal data model. So once you've added a file to Git and once you've committed it, it's there forever. And you should think of your repository as a collection of files, not as individual files with a history. So what you're recording in Git is not the history of individual files. You're recording the history of a directory. You're recording the history of a collection of things. And this is where I need to bore people with a little bit of the software side of things and add some terminology. Git has something called the index or the staging area, and your life with Git will improve considerably if you can bend your mind around this. In other revision control systems, once you commit a file, that's all you need to do, because Git tracks the entire repository and tracks changes. You need to go through something called the index or the staging area. More recent versions of Git have started calling it the staging area more or less consistently. Your files in Git are in one of three stages or four stages. If they're untracked, Git simply doesn't know about them. They're unknown to Git. If you delete them, they will be gone because Git has never known about them. But once a file is tracked by Git, it's in one of three states. It's going to be modified, in which case Git knows that there's a previous version of this file. It knows what it looks like, and it knows that you've changed it. If you want to keep these changes, you'll need to commit them. But before you can commit them, you'll need to stage your changes in the index so that you can commit them. And the staging area or the index is really nice because you can move things in and out of the index. So you move partial changes into the index. So for an individual file, that looks a little bit like this. Your file starts on the left side of the diagram. Your file starts untracked. Git has no idea what this file looks like. You can add the file. If you add the file, it becomes staged. So Git adds, puts your file in the staging area. You can keep changing your file. So you edit your file and it goes from unmodified to modified. And then you can stage it again and it goes into staged. But only at the point where you commit your file will Git realize that it's now an unmodified file. If you remove it again, it'll be, it'll be tracked. But the index is where you go to make your changes. So let's go back to my terminal window again and show how this works in practice. And I'll also try to show it using source tree because the command line is all very well for those of us who live in command lines, but it's not particularly friendly if you simply don't live in a command line. So let's go back into my terminal window here. Oops, it's a lot easier if I spell things right. Git log, I have one commit here, the one I committed earlier. Imagine I now create a new file. If I do git status on this new file, Git says there is one untracked file. Git does not know anything about this file. If I delete this file, it will be gone forever. My earlier file is still there, so my readme file is still there. To tell Git that this new file exists, I need to git add my new file. If I do status again, Git says, hey, your file, this is a new file, and this is now in your staging area. It's in the index. If you git commit, it will be in there forever. But imagine I change my mind about this file. I don't actually want to commit it. If I now, to remove it from the index, I need to, someone in the chat window says my terminal is not showing. Is nobody seeing it? Oh, okay. Might be a local problem. Okay, so it's a local problem for the first commenter. All right, so I can remove this file from the index again. The command to use there is git restore. It says helpfully. So git restore staged my new file, the file is now back to being untracked. So Git knows nothing about it. Let's add it again because I actually want this file. But what if I make a change to this file before I commit it? Let's type something into that file and look at the status again. Git says, hey, this file is in the index. Next time you commit, there will be a new file in the repository, but you've made some local changes to this file as well. So when you commit this file, these local changes are not going in there. So if I git commit now, I will get an empty new file.txt added to the repository. I won't get the hello line added. To add the hello line, I just do git add again, and now the file with the line is ready to be committed. And again, I can restore it to take it out of the staging area. I'll change the size of my window to see if that makes it more visible. Oh, okay. All right, so that's basically it. If I now git commit this file, another file, notice if I want to add a one-line commit message, I just do git commit -m, and then that message. You should never do this, or generally never do this in normal operations, but for teaching, this works. So now I've added my new file. If I look at my log, there we go. Let's try doing this using the source tree GUI. So I'll pop that up, and let's see if that wants to work. I will probably have to share this entire desktop. It wants me to. Zoom, your sharing options are a source of constant amusement. There we go. So now let's do the same thing with source tree. We pop into here, and let's say scan directory. My test repository is right here. There we go. So source tree now knows about this repository. As we can see, it's got my my first commits. Can I make this slightly bigger? There we go. It's got my first commits, hello world, in a README file, and my little essay to my future self saying that this configuration works, greeting the world will work.
Just one note, Philip, sorry.
Yes.
Can you maybe increase the text size? Because I think in some screens it might look very small.
I have no idea how do I increase the text size in
just saying it, sorry to interrupt you, but just saying it so that maybe other people were too shy to say that.
Right. I'm afraid I have no idea how to make the text size larger.
Then let's go ahead like this. But
in this, no, I have no idea.
Okay.
I'll make my terminal window larger and focus more on the terminal to other Philip's great amusement. So you have your repository source tree knows about it. Control plus does not work in this thing. It does not, and I'm not going to mess with my resolution. All right, so let's go back to here. So if I add a file here, I just create another file, and if I go to source tree shows me that, hey, you have uncommitted changes. This is the same thing as git status. I'll make this one bigger. There we go, to overcompensate. This is the same thing as git status saying you have an untracked file here. So with source tree, I can also add this file to my repository. I can say, I want to commit this file. So I press the little commit button, and you have the same sort of user interface. And this is where you write an essay to your future self. and we'll commit that one. We have to select that one because you can selectively add things to your repository. You don't have to commit the entire file. Maybe you only want to commit a couple of files. So you click the commit button, and source tree comes and asks you many exciting questions. You say, fine, that's done. And the Git repository knows about it. It's right there. To see the contents of that commit, I can do git show. It shows me, hey, you've added another file. You can do this just as well in the GUI. It doesn't matter which of the two you use, whatever you're comfortable with. I prefer the command line because I'm a cranky command line user. If you prefer the GUI, that's fine too. Just bear in mind that most of the documentation for Git is aimed at people who use the command line. So I hope this presentation will help you map the command line concepts to the user interface. So let's go back to my presentation, which has larger texts. Oops, slideshow. Zoom, do what I mean. There we go. So staging changes, you do git adds. You can do git add minus patch to only commit or stage parts of a file. And you can go back and forth, adding and removing things from the staging area until you are happy with what's in that staging area. What's in the staging area will be what you want to preserve forever. You may still end up with local changes, which you can see with git status and git diff, but what's in the staging area is what's going to be in your repository when you type git commit or when you click the commit button, and that's what your commit message, your essay, your notes to your future self will describe. So the staging area often confuses first-time Git users because other revision control systems don't have it. The trivial use of the index is, you git adds, git commits, and you might think that the index gets in your way. But another way to think about it is it's a staging area where you can put parts of your changes until you are happy with them. And manipulating the index is fairly straightforward, both on the command line and using something like source tree. I don't know of other Git GUI interfaces, but source tree definitely manages the index in a way that's moderately intuitive once you realize what the index actually is. Now we need to go back and bore you with a little bit more theory again. Branches, and this is where most people get turned off by Git. As the XKCD comic I showed earlier says, as soon as you get yourself in a pickle with Git and you've phoned a friend, the first thing that friend will do is he'll go off on a tangent for half an hour talking about branches. I'm going to try not to talk for half an hour about branches and stick to the things you actually need to know. So a branch is conceptually just a label. It's a pointer to a snapshot, and a snapshot is a commit, which Git knows about. So internally, it's a content addressable file system, and it's a hash, and it's a whole bunch of stuff, and there's a whole bunch of objects, but you really don't need to know these things. The only thing you need to know about a branch is that it's a name for a snapshot. And the name can be anything. There's a couple of special names like head, which I'll talk about in a moment, but it can be any name you like. By convention, the default branch of a repository is known as master. Sometimes it's known as main, but it can be anything you want it to be. And the only thing a branch is it's a pointer to a snapshot. So on the diagram on the left here, we've got three snapshots or three commits. Snapshot A, the hash of that snapshot was 98CA9, B, and C. These are different versions of your repository. They're not versions of files, they're versions of your entire repository. On top of that, we've got two boxes, the red boxes, are branches. They're just pointers. They just say the thing named v1.0 is snapshot C. The thing named master is snapshot C. They're friendlier names than your the hash of its contents, and it allows you to refer to these things by a name you can remember. The top of the diagram, the head, is a magic pointer, and this one moves with you. This points to your currently checked out branch, your currently checked out commits. So when a software person thinks of Git as a content addressable file system, what we are thinking is the way the head pointer moves to our different contents. You can largely ignore the heads. It's just every time you see the word head somewhere in Git, remember that it's just a pointer for your current branch, and it's not like head in Subversion or CVS where it's the latest version. Moving on, I will show how that works on a terminal in a bit. Let me just go through the theory for a moment longer, and then I'll do the demo. So to create a branch with Git, you just create a new pointer. So if you do git branch testing on our diagram here, we'll just add a new little label to that same version. No new version is created, no new contents are created. It just adds another name for the snapshots that already exist. So now you have two branches, and they happen to be pointing at the same contents. You'll notice that your head does not move at this stage, which is an odd sentence to say out loud. Your head does not move, it just points at master still. When you switch to another branch, what you do is you move your head. So git checkout testing, checkout is the command for moving to another branch. Newer versions of Git also supports the switch commands, but most documentation on the internet will use the checkout commands, and checkout is an awkward word for this operation for people who come from other revision control systems. So what the git checkout command or the git switch command does is it moves your head pointer from where it was on master, and it moves it to test or testing. If you commit to a branch, no matter which branch you are on, you're going to create a new snapshot, and your existing branches are not going to move. And that's what makes branches powerful in Git. They are just labels for snapshots, so you can create them with enthusiasm, with reckless abandon, without worrying about occupying more space. It's really just a pointer. So if you commit a change, you edit file.txt and you commit your change, obviously after adding it to the index, you're creating a new commit, your head points at that new commit, and the branch you were on also points to that commit. If you then switch back to your master branch, git checkout, this is a typo, this should say master, git checkout master, your head moves to that branch, and the new commit is there. You can always find it. You can find it by the label testing, but you can also find it by its checksum. Let's do that in a terminal window, which may or may not make more sense. So we have our nice large text. I just do git branch testing. Nothing changes. So Git doesn't even tell me anything. It just accepts my commands. Underneath the guts of the system, it's gone and created a new pointer for me. To actually use this branch, I need to check it out. So I can git checkout testing, and now I'm actually on this branch. If I do git log, I still have all of my changes, and the first line of the output says that head is pointing to the testing branch and the main branch. They're both pointing to the same commits, and there's no changes. If I add another file here, and it'll just be an empty file for testing. There we go. If I do git log again, git shows this empty file here, my essay to my future self for my previous commits, another file, and my first commits. If I now go back to my master branch with git checkout master, oops, I called it main, I'm sorry, and look at my log, I see this commits, that commit, and that commits. There's no sign of my empty file because this empty file does not exist on that branch. You can do the same thing with source tree. Let me do that again. If I can find my source tree window. I need to just share the desktop. Here we go. Source tree. With source tree, if you want to create a branch, source tree notices that there's 2 branches, by the way, it does that instantly. If I wanted to create another branch, say from main, I'll go from here. Source tree will ask me, where do you want to create this branch from? You can create it from testing as well, but let's keep it simple and branch it from main. Let's call it more testing. There we go. And I will just create this branch from the top of the master branch. Source tree will offer you whether you want to check out this branch or whether you just want to create it. Checking out a new branch changes your workspace to track that branch. Otherwise, it does the same thing as git branch, and it just creates the branch and does nothing. So in the interest of doing the same demo, I'm not going to check it out and just create the branch. Now there's a new branch here. Main and testing are here. The testing branch has this empty file. This empty file does not exist on the more testing branch. If we go back to the terminal window, you'll note my terminal is still on the main branch, but I can check out more testing here. And indeed, I see my 3 commits, not the others. So let's go back to my PowerPoint, getting better living with Zoom again. Slideshow, there we go. And share my slides. There we go. Right, so that's really the only thing as a network engineer you need to care about with branches. They're just labels, they're just names. You will probably never encounter a situation where you have to merge 100 different branches that are all diverging. And all you need to remember about branches is they're just a label for where your snapshots lives. It's an alias for your snapshots. Unfortunately, I do need to talk about branches, to this extent, because they're important for collaborating with others. This is a final diagram I want to share about branches. It's when history diverges. So if you commit a change, you're going to add another snapshot. So imagine you're on the master branch again, and you add another commit. That one goes there. Your testing commit still exists, and it's still in Git. It's still known to Git, but your history now diverges. So if you want to take this commit to that branch, you'll need to merge it or do something to it to make Git happy, and we'll come to that. So that's really all I want to say about branches. A book about Git or most other workshops and tutorials about Git spend an hour on branches alone, and I'm just not going to do this. You don't need to know anything more about them. You can use your branches to track your name. Yeah, you can use your branches to track your changes, and Git will can remember for you where you've been. So if you're collaborating with multiple people and you find yourself having a whole bunch of branches and you can't see the forest for the trees, you can use the ref log in Git to show you where you have been. So Git reflog will give you a list. The screenshot is here. I'll keep talking a little bit more before I go back to the terminal, because otherwise I keep going back and forth. So the reflog will remember every time you do Git checkouts, or every time you do Git commits, or every time you do something that moves a branch forwards, Git will write an entry to the reflog. So if you've been fighting with Git for half an hour and you can't remember how you got to where you were, you can do Git reflog, and it will show you where you've been and how you got there. And it will also show you the commits that brought you to where you are now. So if you've added something, you've committed a change, and then you've switched to a branch, and you've committed other changes, and you're worried that you might have lost a change you've committed, chances are very good that you've not actually lost it. As I said at the beginning of this presentation, it's quite difficult to lose data with Git. Git reflog can show you where you've been, and you can then fish up that commits and bring it back in a number of ways. You can use Git resets to move the little label, the head label, between branches. I'll come to that again in a little bit. The one command to remember from this slide is the reflog. If you've been merging things and been fighting with Git and you think you're lost, take a look at Git reflog and you'll probably find your changes again. I haven't been able to find a reflog in source tree. I suspect because source tree has a slightly prettier and easier overview of what branches exist and where you might be. Or maybe I've not played with source tree enough. So that's all I wanted to say about local Git repositories. Now let's come to the fun parts of this presentation, collaborating with other people. Git is perfectly useful locally. You can manage your own files in isolation forever, and there's no need to share everything you've put in Git. I use Git to manage things like invoices I write, or I use Git to manage notes to myself, which are not for sharing with other people. But where Git really shines is it allows you to collaborate easily with other people by sharing your history and sharing your commits and sharing your repositories. Git is known as a distributed revision control system, which means your entire repository is shared. Every Git repository is a copy of the entire history with all the contents and all the metadata inside. Git's a remote repository is not like a Subversion or a CVS checkout where you've only got the latest version. If you clone a Git repository, you have the whole thing. And if you add a remote repository, you're going to share your entire history with it. It's possible to selectively share parts of the repository, but that's not what Git was made for. It's also worth pointing out that a remote repository can exist somewhere else on your machine. It doesn't have to exist on the internet. So imagine, if you're using this to track your notes to yourself or invoices, you can add a remote to another part of your file system, and it will work exactly the same as if that remote were on another server somewhere. There are several workflows with differing complexity for remote repositories. The internet is full of documentation with scary terms like integration branches and staging branches and lots of complicated merging terminology. You generally don't need to care about any of this in the vast majority of applications you're likely to encounter in the real world. Everyone will have a clone of a shared repository, and everyone will push their changes and pull their changes from that one shared repository. You can share your work sideways from first developer to the second developer, first engineer to the second engineer, but most use cases you'll push to a shared repository and pull the changes from others from that shared repository. And we'll look at the GitHub workflow in a moment, which is basically this with a nice web user interface around it. So now I will go back to my my terminal window and show some more Git voodoo, and then I'll do the same thing in the source tree because some people like using user interfaces. So I have this repository which now has 3 branches on it, and I don't remember how many commits. So it's got a couple of commits here. Let's move back to main. So git check out main. And yes, as I said, reflog is helpful. So the reflog tells me that, hey, I created a commits earlier. I created another commits. I moved from testing to main. I moved from main to more testing, and I moved from more testing back to main. So the reflog tells me where I've been and what I've been doing. If I now want to share this repository with other people, I can just take this .git directory, which is my entire repository with all its history, all its data as well. So the contents of these files also live underneath this .git directory. In the simplest possible case, I could just take this .git directory, tar it up, and send it to someone else, and they would have a complete copy of my repository and the history, and they could send stuff back to me. That's not really a friendly way. So let's imagine that we want a shared repository to collaborate on this my test repo. The way you do that is you create a bare repository called, let's call it shared repo.git. So this is an empty repository, and it's not even checked out. So it just exists as a place to share files. Currently, this one has nothing in it. I could also just have taken this .git directory, and copied it to something called shared repo.git. I'm not going to do that because that's a bit superficial. Let's go back to my test repo and now say, okay, I'm collaborating on this project with someone else, and we have a shared repository. Usually the shared repository will live somewhere like GitHub or on someone's server. But in this case, it lives in another directory on my file system. That could be an NFS directory for that matter. The point of this demo is to show you how do I tell Git about this new remote repository. It's quite intuitive. You just say git remote add, and every remote has a name, and the name can be anything you want it to be. Usually, if you're collaborating on a shared project, the convention is that your shared repository is called origin, and it helps if you spell it right. So we say we add a remote called origin, and then we give it the path of that remote, which can be a URL, or it can be on our file system. And Git just accepts this. This is very similar to Git's branch. Git just goes, okay, that's fine, cool. You've told me about a new origin, but we're not doing anything with it yet. If you wanted to fetch data from this origin, you've just added, you would have to git fetch origin, say. Git again says, that's okay. There was nothing to fetch because this was an empty repository. If I wanted to share my changes with this remote, I would push these changes. And in this case, I'm just going to push everything to origin. You can also, by default, it will push the branch you're on. But in this case, I'm going to push all my branches for a better demo. So let's do that. And now Git tells me that, okay, I found 11 objects, whatever they are, commits, trees, files, all that sort of stuff. It's compressing them and it's doing things and it's dumping them over there. That shared repository is now available to share with other people. If I go back and I say, okay, I have another collaborator and they want to take this repository and work on it together with me, they would clone this repository. So let's clone, what was it called? Shared repo.git, and let's call it, copy of test repo. There we go. So if we go to our test repo and we do a git log, we see the same commits we had earlier. We have a couple more labels, and that's why I spent a little bit of time talking about branches. Every origin you add, you track their branches as well, and they get a little label added to them. And these labels are exactly the same as your local labels, and they're nothing special. They're just there to tell you that, hey, you have a remote called origin, and on this origin there's a branch called main, a branch called more testing, and all of these are the same commits. And that's where Git really shines, is you just add another label, you just add another little tag to it, and you can track branches from other people easily. You can add more origins. You can add as many origins as you like. The origins can be local to your computer. They can be on GitHub. They can be on someone else's server. And they look like branches to you, and they won't be any different from local branches. To keep them up to date, you do git fetch, and to push your changes, you do git push. But to Git, it's just a branch. There's nothing special about a repository hosted on your machine versus a repository on GitHub or a repository you're currently working in. They're all the same, and the minimal knowledge you have about branches is enough to get around with them. So let's look at how SourceTree treats this. So I'll go back and share that window here. We'll go back to that and look at SourceTree. If I can find it, here's my SourceTree. The SourceTree has, there we go. SourceTree has noticed that I now have a remote. I had to press the little arrow button here. And I'm sorry if my text is too small. I would encourage you to just play with this on your local machine with a test repo. So I've got a remote called origin, and it's got 3 branches, the same 3 branches I have. I can add another remote if I want to, but I don't have another remote. So the remotes can have a name, and it can have a path or a URL. So this could be a pointer to GitHub, or it could be a pointer to my local machine. And the other bits you simply don't have to worry about. But in SourceTree, this looks exactly the same as it does on the command line. Your remotes are listed here. Every remote has a name. By convention, origin is the name of a shared repository you use by default. This could have any name you wanted. And underneath the remotes, it shows you the branches that remote has. If you commit, you're staying local, but then if you wanted to share the commits with your remote, you would use the push button here to do things. So I can, this is my copy. Let's go back to my test repo and just add another demo file. There we go. So I've created another commit here. And now SourceTree notices that branches have changed. So I've added a file to my main branch and the testing branch and the origin testing branch are still pointing at the previous commit. If I wanted to share this commit with others, I now have to push this commit, and it will ask me, dear Philip, where would you like to push this commit? I would like to push it to origin, please. And it helpfully also tells me where origin points. If origin is on GitHub, it would tell me GitHub here. Which branch do I want to push? Well, I'm only really interested in the main branch. The others don't have any changes on them. The track column here on the right is interesting. If you type git push without any arguments, depending on the version of Git you're using, it will either push all branches or no branches or the current branch. And the track bit says whether you want to push this branch to that remote branch by default. Let's just check that box because that's usually what you want to do. And don't worry about tags. Tags are irrelevant. You just say okay. And now my extra commit has been pushed there. So if I go back to my my copy, you can log here. I don't see this change. I need to fetch my origin. Git fetches the changes from the shared repository. Sometimes you'll see this spelled as git pull. Pull does a fetch and a merge. I usually prefer to teach fetch because it's a little bit more obvious what's happening. And Git tells me that, okay, I found a change on the main branch in the shared repository. I've written it to your origin main branch. If you want it, you can merge it from there. Or, if you don't want it, you can just ignore it. If you want this commit, you can git merge your origin main. And if I just log here, I've got it there. If you type git pull instead of git fetch, it will do the merge for you. I prefer to do it in 2 commands because I'm a control freak. With source tree, it's the same thing. You can do fetch or you can do pull, and you would use the merge button to merge the remote changes back into your repository. Let's go back to my PowerPoint slides. Zoom. There we go. There we go. Right, so using remote repositories essentially boils down to telling Git that you have a remote. On the command line, you would type git remote add and then give the remote a name, origin by convention. It can be anything you want it to be, and then the URL, which can be the path to a directory on your local file system or NFS. To share changes with remote repositories, you do git push. And to get changes from others, you do git fetch from a specific remote or from all of them. You can merge changes from others using git merge, as I showed, or using git rebase. The differences between merge and rebase are subtle and interesting. Generally, type git rebase or use the source tree repo. Merge will create a merge commit and it'll make your history interesting. Rebase will just rewrite the commits on your history. And that's really all you need to know about Git. There is nothing else that is relevant about Git to casual users who are not software engineers, who don't have to merge divergent histories of developers working on feature branches and wrangling source trees. All that matters about Git to network engineers is how do I write files to my repository? How do I track my history? You can do that on a command line, as I showed, or you can use source tree. it really doesn't matter what you use. I find source tree easier to understand once you've understood what a branch really is. So a basic understanding of branches and of the index will make source tree easier for you to use. So if you prefer to use a graphical client, go and use source tree. I'm not going to tell you to use the command line, but as I've showed you in the past half hour or so, the command line really isn't all that scary. And while it was very fragile in earlier releases, it's become a little bit more helpful and user-friendlier in recent years. And armed with the reflog in particular, you're less likely to find yourself in a maze of twisty passages all on fire. So play with both of them and see what you like. I like the command line. The source tree works just as well. If you can master a little bit of the terminology of Gits and the basics of branches, source tree should make sense to you, and so should the command line. So having talked about Git for the past 40 minutes or so, let's now talk about GitHub. GitHub is a place where you can host your repositories to share with other people. And they also have a bunch of other collaboration tools. So it's superficially targeted at software projects, but really Git doesn't care what you put in your repository, and neither does GitHub. So documentation will work just as well, even binary files. Anything you can put in a Git repository, you can push that Git repository to GitHub and collaborate on it with other people. GitHub has a bunch of nice things in addition to just hosting Git repositories. They also have an issue tracker, something called pull requests and wikis. So if you're, imagine you're the manners community and you're collaborating on policy documents or norms for networks, you can collaborate on GitHub just as well. You write these documents, you push them there, and you can use the issue tracker to discuss changes with the community before they end up in the repository forever. GitHub has a specific kind of workflow, which again is geared a little bit towards the software mindsets, but it works just as well for networking people or any other kind of people. The way GitHub usually works is you fork a repository from a project, and fork means you make a copy of this repository in your namespace. So you have a GitHub account under your name, someone else or the project has an account in their name. When you fork a repository, you make a copy of it under your namespace. Then you go and clone your fork locally. So you git clone on your laptop or your desktop or whatever, and you make your changes on a branch. You push this branch to your namespace on GitHub. And then, so that up to this point, it's really just Git. And then you create something called the pull requests in the project repository. And GitHub provides collaboration tools and really an interesting sort of web interface to discuss this pull request. And eventually, once that discussion completes, the project owner will merge your accepted pull requests into the shared repository, and anyone else who clones it can fetch those changes from it. And it's really boring just to talk about this. So let's have a look at a GitHub project. Share another screen. I've lost my window. Oh, here we go. I'm using Dim Sum Labs, which is my local friendly hackerspace I help run, because it's an organization with a bunch of different repositories, which I also happen to control. If I wanted to create a new repository for collaborating on, say, the demo projects I've been talking about for the past 45 minutes, I would say, I would like a new repository, please. The owner of the repository, this could be you, it could be your organization. GitHub has a thin distinction between people and organizations. As far as I can tell, an organization is just a special kind of person. So I'll just call this one manners Git demo, and I'll take it away again. All right, and I'm going to make this repository public. You can make it private as well, in which case you'll have to deal with GitHub's access control lists to decide who you want to share this repository with. If you're using GitHub's organizations, you can pick people within your organization at will. You can also share it with external collaborators. You can initialize this repository with a README file, a gitignore file, and a license. But in this case, all I want to do is push the repository I've been working on already. So I'd like a blank, empty repository, please. So I will just create this repository, and GitHub goes and does things, and it provides you some helpful, more or less, information on what you can now do with this repository. The thing we care about here is this bit, is if I want to have a remote, I want this. Let me copy this and go back to my command line for a moment. Actually, let me just share the whole screen. That will be clearer. If I could find my terminal window, that would be nice. So here we are. That's a copy of the test repo. Let's go back to my test repo. And I can git remote add, and it needs a name. I'm just going to call it GitHub, and then paste the URL I got there. You can do the same thing in source tree. You can say remotes, add a remote, but the text size of my terminal is larger, so I'll do it on the command line. I do that. There we go. Again, Git just accepts this and doesn't ask me any further questions. If I want to share these changes, I need to, I can git push, again, -- all, and let's say I push these changes to GitHub. What this does is it will take all of the commits I've already got, all of the history and all of that stuff, and it will park it on GitHub. Let's do that and watch it fail. And it complains about my public key. This works over SSH. It'll work better this way. There we go. So it's done that. It's pushed exactly the same way as you would push to a local repository. It's now pushed it to GitHub. So if we go here, back to our GitHub thing, and take a look at the repository, we find that, hey, I have added, this looks very familiar to us. This looks exactly like what we saw in source tree. This looks exactly like what we saw in my terminal window. I've got 4 commits right here. Some people might actually like the GitHub GUI for Git better than the source tree or Sublime or some other thing. And you can collaborate on this. So I've got a branch called testing conveniently there. And I can say, I'd like to make a pull request, please. So you do compare this branch and create a pull request. What's in this branch is, well, apparently there's an empty one in there. So you would write a little comment and describe the changes you've made. So there we go. So let's create a pull request for this. And GitHub is doing its little magic. And now you have your pull request on this repository, and anyone else can comment on this pull request. So if anyone is, watching this repository, it's a public repository. You can do, you can collaborate with me on this completely fictitious, empty, and practically useless repository. Other people can now, comment on this change. If you feel the file should not be empty, you can write a little comment to that effect. You can also fork this repository. If you do fork here, you can you can fork it into your namespace. There we go. This takes a couple of minutes again. This is a little contrived demo because I have push access both to the Dim Sum Labs organization and obviously to my own namespace. So ordinarily, I would now add a remote to this GitHub repository rather than the shared one. But it's equivalent in every way. A remote is a remote. So let's do exactly that. Let me clone this one. Go here, and let's try doing this one on source tree just for fun. I'm almost out of time, I think. Just about done too. So let's say add a new remote. Call it. Let's give it my username, and again do this. I have no idea if source tree has access to my SSH key. I'm about to find out. If we do that, that's all good. Let's fetch from all remotes. That works remarkably well. So now I have 3 remotes here. I've got the origin, which is the directory on my computer. I've got Paeps, which is my GitHub namespace, and then I've got the shared GitHub namespace. Usually you wouldn't have this one, and you can add commits here and push them. Let's push this one to my GitHub namespace. There we go, that worked. So if we go back to our little GitHub window here, we should see that I am 1 commit ahead of the shared repository. So I have 1 commit in my repository, which is not in the shared one. I can, if I wanted to, I can create a pull request for this one. And have another discussion about that. So the GitHub system allows you to collaborate in a fairly clean and tidy way using a web interface. So you put pull requests where you go and discuss changes. You have issues, which is mostly for software people. They would be bugs, but you've also got a wiki. So every project on GitHub can also have a wiki where you can keep the documentation for that project. And GitHub has fairly robust access control and sharing features which you can use for managing access to this repository and collaborating with other people. But fundamentally, if you understand Git, it's really just a remote. So the way you interact with it is either with source tree or on the command line. You just push changes and fetch changes from it like you would any other remotes, and they show up on their web interface. So let's go back to my presentation and wrap things up. I can find my presentation. There we go. And share my presentation. There we go. Right, so finally, GitHub also has some nice integration with continuous deployment and continuous integration workflows. I knew I was going to be out of time by the time I got here, so I didn't delve into it any farther, but it's worth clicking around on GitHub and just seeing what's there. I would not recommend using GitHub to manage your network. I think that would be a terrible idea. But if you're collaborating on some documents or an internet draft or on even an access control list with a bunch of people in a Git repository, you can use GitHub automation to turn that file or that access control list or whatever it is into different formats. You can use GitHub to do some testing on it before accepting pull requests. So when you submit a pull request, GitHub can do some automation on it and just give it a sniff test. And that's worth looking at. Finally, we get to the end of this presentation. Most of the images I use today have been copied from the excellent Pro Git book, which is available on the internet on gitscm.com. It's under a Creative Commons license, so you too can use these images, provided you give credits and share your images too. You should really read this book. A lot of the book goes into details you don't need to know, but if you just let your eyes glide over those details, you'll find that it's actually quite readable, and it explains Git in a level of detail that's appropriate for any audience. I've also put 2 pointers to cheat sheets here. GitHub has one which looks a lot like the slide I had earlier with the commands you need every day. And then there's one which I really like is how to escape from a Git mess, which shows you a little flowchart where help, everything is wrong, and Git is shouting at me, how do I get out of here? That flowchart is worth looking at. And that is all I have for today. I hope that was informative. I don't know, do we have time for questions, Aftab?
We do have 2 minutes if anybody
All
wants to
right.
ask any question. But of course, if you can, well, your email address is right in front.
My email address is there. I reply to email.
It could be trouble-is-Philip, but yeah, it's Philip at trouble is.
All of it works.
Yeah, so I think it was really interesting. Some of, at least from the Git, the hosted Git is still confusing for a lot of people. And I was talking to Philip Smith a moment ago, and he was saying when he started working for MSRC, the first thing he heard was all the repository is in GitHub, and it was like, okay, why? so these are the things we need to for at least for the network engineers, they should learn these things. What is the difference between a pull and a commit? So it was really very interesting.
Yeah, I tried to explain the concepts rather than doing cookbook style, because I never think cookbook style is very gratifying. But yeah, GitHub is really just another remote with a friendly web interface. It's nothing to be afraid of.
Good. So thank you so much for that, Philip. I wish we could do something in person with everyone bringing their laptops and creating 20, 30 repos which we can all collaborate on. But 2021 is not the year for that. Hopefully 2022 is going to be for that. And at least I'm looking forward to it. But on that note, I would say thank you so much for your time, your efforts. We will upload all this. I mean, it's already available on now YouTube and on iSoc.live. So anyone who wants to review at the later stage, they can. But hopefully next time we will do it in person if the stars are aligned somehow. But thank you so much for your effort.
Yes, thank you for having me. Let's do this again someday.
Yes. Thank you, everyone. Hope to see you all again somewhere, someplace. Till then, take care. Have a good day, good afternoon, good evening. From myself here, good night.